Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome back to the second section of our Undip Group Classroom, ya UGC, Guest Lecture Program organized by Department of Mathematics, Faculty of Science and Mathematics, Diponegoro.
Kalau pagi kan juga ada aku tidur.
Okay, it is great pleasure for us to continue our academic section with our distinguished guest lecturer from Universiti Teknologi Malaysia, Dr. Normah Maan. Oke, Assalamualaikum, Dr. Normah.
Okay, Waalaikumsalam warahmatullahi wabarakatuh.
Okay, in the previous lecture, we learned about the fuzzy number and arithmetic operation in fuzzy set theory. Today, we will continue with another topic in fuzzy mathematics, and we'll further enrich our understanding of fuzzy set theory and its application. Okay, we are grateful, to Dr. Nama for her time, dedication, and willingness to share her expertise with our students to this international academic collaboration. Okay, I hope all students will actively participate, engage in discussion and gain valuable knowledge for today's lecture. Without further ado, let us warmly welcome once again our respected speaker, Dr. Normah. The floor is yours, Dr. Normah. Thank you.
Okay, thank you very much for the opening session, Pak Jovian. So again, today we see again class. I really hope that the lecture that I have given to you yesterday, you understand, and that there are some exercises at the bottom of the notes. Maybe you can try also. So today we plan to continue the arithmetic operation on fuzzy numbers, but more specifically to explain about how the multiplication using two methods. We have Afaka method, and also we have another one is extension principle method. So depending on the type of the fuzzy number given to us. So, but before we proceed to that one, I think I would like to do some sort of revision little bit on what we have yesterday. Okay. So I will share my screen. So okay, so this is actually we want to continue to the multiplication operation, but I think when we refer back to the exercises that we have before this is on this one is the addition, okay, at which we use two methods. The first one is Afaka method, where the nature, the properties of the fuzzy numbers involved in the form of continuous function. But for the extension principle method, we use it specifically if the fuzzy numbers in terms of this kind, for example, like this one, which is a discrete one. So before we go further, all right, to have the multiplication, I think I would like to give some more example. Okay. Hold on. I think this is multiplication. We go back. Okay, all right. So here I think, so now I would like to give you one more example, which is like, for example, we have two fuzzy numbers, A and B. Okay. Let's say D is A. Okay. Which is A, this one in terms of trapezoidal. Okay, because I think you are familiar with triangular fuzzy numbers. Now we go to trapezoidal. 1, 2, 4, 6, for example. Then we have B. B, like say we have 3, 5, 6, 8. Okay, this is a very simple one, and also I think you be able to sketch the trapezoidal, which is we have, let's say, 1, 2, 4, and 6. So this is the diagram will be look like the trapezoidal one. So this is the one. So this is which is one, because this is a fuzzy number. So when we talk about fuzzy number, the membership function or the fuzzy set must be normal. So normal meaning that the highest fuzzy value should be equals to 1. So another one, lady, is your A. Then another one we have B. B we have, for example, this is 3, 5, 6, and 8. So the trapezoidal fuzzy number will look like this one. So this is 1 also. Then this is 5, and then this is 6. So this is one way to represent your trapezoidal fuzzy numbers, where you can see there is 4 component in here, representing each of these representing the value of this one, 2, 4, and 6, and so on. So beside that, you can also represent this one in terms of mathematical equations, which is in this case for the A1, you will get x minus 1, okay? X minus 1 over 1. So which is this one, your x should be greater than equals to 1, less than equals to 2. And then you will get 1 here will be your x greater than equals to 2, less than equals to 4, which is this one, okay? So and then the next equation is representing this equation. So what you should have is 6 minus x over 2, which is this one is between 4 and 6. Okay, and we can also identify this membership function, or the fuzzy number here will be equal to 0 otherwise. Okay. So the same case with your B here, you can also, this is just involve arithmetic, very simple arithmetic method to get what is actually the equation will be represented of your fuzzy numbers. So this is 5. Then again here 1, when your x between 5 and 6. Okay, you just refer to the diagram. So this one 8 minus x over 2. And then this equation representing the slope of the line. So x greater than equals to 6, less than equals to 8. Then here again is 0 otherwise. So definitely this type of fuzzy number, what we need to do, we need to use the alpha cut method. So again, alpha cut method, even though D is actually a trapezoidal fuzzy number, the method that you need to use in order to get your alpha cut is still the same as what you have applied for the triangular fuzzy number, where we know that this slope, okay, representing the value of x. So you can say that your x here, your x here, which is equals to x minus 1. And then definitely you will find out your x here, which is basically will be equals to the interval of alpha plus 1. So the same procedure, okay, I just give the answer. I think you can do on your own here. And then also your BX. BX, the same methodology you apply to this membership function, you will get BXU, which is equals to 2 alpha plus 3 alpha minus 2 alpha, 8 minus 2 alpha. So this is quite easy if you want to check back whether your calculation is correct or not. By substitute the value of alpha, either alpha is equal to 0 or 1. So in this case, you look into this one. If I put my x here, is my alpha is equals to 1, so I will get 2, which is this value. Okay. When I try to another one, the other end, your alpha is equals to 1, 6 minus 2 will get 4, which is this value. So this is the way how you want to check whether your answer is correct or not. If A alpha representing alpha cut for the triangular membership function, when you substitute value of alpha inside the equation, you will get only 1x, because you know that triangular membership function only have one peak, not like this one. D is trapezoidal, you will get like interval of the value of x for alpha is equals to 1. So when you have this, so the next one is the normal procedure. So you need to, when A alpha plus B alpha here, the same case class. So since D is actually addition operation, so uh, the methodology is quite straightforward. So you just add this value to this one, and then another end you will get add this one to this one. So it's very straightforward. It's very easy. So you will get here is 3 alpha, okay, plus 4, and then this one should be equals to 14. Okay, 14 minus 4 alpha here. So this is actually your C alpha. If I let my C is equals to A plus B, so your C will be equals to A plus B, right? So when you want to get A plus B here, this is the concept of first decomposition theorem need to be applied here. Need to be used, Need to be used. So for first decomposition theorem, you understand that actually you can get C. C is actually the union of S of C alpha here. Sorry. Alpha, you will get C alpha. You know that your alpha should be is a element from 0 to 1. Okay, so you'll get something like that. So using this first decomposition theorem, what you should have, your C should be equals to which is A plus B here will be equals to x minus 4. So this is like what we have done yesterday. So 4 x greater than equals to 4 less than equals to 7. Then you'll get 1, your x greater than equals to 7 less than equals to 10. And then 14 minus x over 4. D is for your x greater than equals to 10 less than equals to 14. And then the rest, this one will be 0 otherwise. So this is quite straightforward for the addition. So the same thing that you need to do for the subtraction for the trapezoidal fuzzy number, the same procedure, but for the subtraction, you need to be careful for when you're finding the subtraction of 2 alpha cut, okay? So now I think I just give a little bit refresh what we have yesterday, but using another type of example, which is trapezoidal fuzzy number. So really hope that you manage to do this kind of problem. It's quite straightforward. Now we go to the multiplication and division of fuzzy number, but this one still we use the we use alpha cut method, okay? We use alpha cut method here, okay? This one we use this. Oh. There is no highlighter. Okay, never mind. So now we have this one alpha cut method. We still use alpha cut method, but this one for the multiplication and division. So it's actually the step of finding this operation for the multiplication is still the same. What we have yesterday, subtraction and also additions. the difference is only on something like how to identify the minimal value of your interval and also the maximum one. So this is something like, especially when the fuzzy numbers involve negative fuzzy number. So when the fuzzy number involve negative fuzzy number, for example, like if you have something like this, your A, D is triangular fuzzy number, and D is your B, for example, D is your A, D is your B. So if you want to multiply A, multiply B, I think it's quite straightforward. So another possibility may be your A is in the form, D is your A, which is D is B. So maybe you need to be careful how to get the minimum and the maximum. And there is another possibility here where this is, I think, a little bit complicated. So when your A is here, D is your B. When you see that your A, basically the boundary of A actually divided into two parts. The first part is on the negative part. The second part here is actually on the positive part. So maybe D is negative, okay? D is negative part. And then you have another one. Maybe this one, D is your positive part. Okay, so when you want to multiply A and B, you must very careful because you need to identify what is your alpha here, which actually will give a different value of the multiplication. Which one is the minimum one? Which one is the positive one? So in here, you need to very careful, extra careful for you in order to avoid any mistake done by the students, okay? So this one is for the reminder when alpha to ensure the division of A and B, A division B, something like this one. You must make sure 0 actually is not in this one. So if 0 is not in B here, okay? Otherwise, the operation, the division operation is not defined or is undefined. So that's you need to consider to check before you do the operations, okay? So now I give this example. So even though this example also have been shown yesterday in my video, so however, I think maybe is I will explain to you before I give you, like, for example, 10 minutes to perform another example which involve the third cases, like what I have shown, something like here, okay? So now we go we go to this equation or this example. So we have your two fuzzy numbers A and B, which is described by this membership function here. Okay, this membership function and this one. So this one actually is also good for you to get to sketch the diagram so that you can see how. So this one you have 2, you have 3, and then you have 5. So here this is a triangular membership function. So and then another one you should have let's say 3, or maybe I can sketch at the same coordinate. So let's say D is 3, and then D is 3, D is 5. So another one you have 6, for example. So D is D is 6, okay? So then you can sketch the triangular on the same coordinate. So let's say we understand D is your A, and then D is your B. So you must remember when D is very straightforward because both A and B are positive fuzzy numbers, okay? Positive fuzzy numbers, definitely when you want to multiply to get which one is the minimum one, which one is the maximum one, is quite easy, okay? So it's very straightforward because when you multiply this one with this one, definitely you will get the minimum one, okay? Minimum of each of A and B, so you will get the minimum one. And then for the other end, you multiply this alpha cut with this one, so you will get the maximum of these two multiplication. Where finally, when you already identify your alpha cut, which is I already give here, It's very simple. So you just the same procedure. You just use something like this one. You get x minus 2 again is equals to alpha. So you know that your x is equals to alpha plus 2. So that's why you have this. So also to get this one, so also the same, So exactly the same as what we have done. So then afterwards we do the operation of on these two alpha cut. You need to do like A alpha multiply B alpha. Okay, try to produce that. So this is the one that I mentioned to you, which is we try to get the minimum of A and multiply minimum of B, and then this one maximum of A multiply maximum of B. So of that alpha cut. So you will get something like this. This is actually quadratic equations. So you expect that the after the multiplication of two fuzzy numbers, triangular fuzzy numbers, you will get not actually a linear equation. You will get the quadratic. So instead of you get straight line to representing your lower bound of the product between two multiplication between two fuzzy numbers, so you'll get a curve, okay, because in this one actually in the form of a quadratic. So again, when you want to use after you got this one, so let's say your alpha here, okay, your A alpha here multiply B alpha, and when we let this one is equals to C alpha, so to get your C, so this is to get your C here, this is your, you need to use a first decomposition theorem. So again, the same, right? The same procedure. So when you want to use a first decomposition theorem, so exactly you will get something like this one. So this is quadratic. So you need to find out the roots of this quadratic equation. Definitely you use a very simple concept, which is your is minus b, right? Your roots of the equation is equal to minus b plus minus square root of a squared minus 2a minus 4, sorry, I forgot. The equation should be is it b minus b, right? Or minus a minus b plus minus, right? B squared minus 4ac over 2a. So this is the formula. Am I right, Pak Jovian, right? Quadratic formula, I forgot. Maybe today I'm a little bit, last night I cannot sleep. So Pak Jovian, is it correct to get the roots? So you will get this one, okay? You will get this is the one that you get. So actually the notation here is plus minus.
Oh yes.
But here, yeah,
ABC.
yeah. So the roots, yeah. So the roots we get, actually you just substitute the value. Alpha is equals to minus b. So the first equation will be minus 7, okay, plus minus b squared 49, okay, minus 4. A is actually is equals to 2. And then your C is supposed to be 6 minus x. Okay, this
Okay.
one over 2a. 2a, a is for 2 times
Yeah, 4.
4, so 4 here. So this is the equation, but I just would like to ask the student, the notation here is plus minus, okay? But why we choose plus, not minus? Okay, anyone of the student here can answer my question, please? Why
Okay.
you choose? Why we need to choose the plus here, not to choose the minus sign? Anyone? So any of the student, can you answer me?
Apakah ada yang bisa menjawab untuk kenapa di rumus ABC-nya yang dipilih yang positif ya?
No, not negative one. In this case, why? Why student? Are you here? Are you with me right now? Why? Any one of you volunteer? Siapa dapat jawab, nanti saya pergi your university, saya kasih satu present.
Ayo
Okay?
mau diberi hadiah ini.
Any
Ya, mahasiswa di
yeah,
responnya.
mahasiswa? Any answer from you? Why we need to choose? Because you must very careful. The notation plus minus. Okay? The symbol, the operation plus minus. You need to correctly choose either plus or minus. Otherwise, you cannot get the answer. Why? Or otherwise, your answer is wrong. You need to choose this plus, you see? And then here, again, we choose the negative one instead of a positive. We choose a minus instead of a plus over there. But in this one, we choose a plus. Why? There is a reason why. If you understand the concept, then you can answer me. If you don't understand, then you cannot answer. So why? So, okay, since nobody answer me, because we are talking about alpha cut here. So your alpha is always between 0 and 1. Okay? So if you choose a negative value here, so the value alpha here will be negative, which is not in the region of the value of alpha. The same case for this one, when you choose the positive one, you will get the value which is more than 1, which is not in the region. So that's why it's very important for you to understand which annotation, either addition or subtraction in that particular formula that you need to choose correctly. So then afterwards, you will get something like this one class. So then finally, you will get the answers, okay? So I think I have maybe one example for the okay. Actually, for your information, this is another example where where I mentioned that the careful thought must be applied here, because you need to choose something here, which is this type of problem where your A, some part of your A here be a negative one. Okay, so because if I write the example 9, maybe you don't know what actually the equation of that fuzzy numbers. So maybe it's better for me to give the equation to you so that you can do the exercise. Okay, so let me write the equation for you. Okay, so hold on a little bit. I try to find the equations. Okay, so this is example 9. So maybe you can start with this equation. Example 9 that I mentioned inside my slide. Okay, so your X basically is membership function of this one. X plus 2, this is basically over 2. And then you have 3 minus x over 2, 0 otherwise, 0 otherwise. So, and then this is your x between -1 and 1. And then this is your x between 1 and 3. So, bx here is the membership function for b, which is x minus 1 over 2. Then you have x in between 1 and 3. And then you have 5 minus x over 2. This is basically from x from 3 to 5. And then 0 otherwise. Okay. So when you sketch this diagram, so you will get this -1. D is 1. D is like, for example, 3. So you get something like this. So, and then this is your A, and then your B, you'll get, this is very straightforward, 1, 3, and 5. So you'll get this. So this is 1. So this is actually also 1. So when you want to multiply, you try to find your alpha cut here. For example, your A alpha here is equals to, I think every one of you will be able to find your alpha cut, 2 alpha minus 1, okay? So, and then the other n will be 3 minus 2 alpha. Okay, this is for B, this is your B. Then for B, the alpha cut B alpha here will be equals to 2 alpha plus 1, very straightforward. And then the other n will be 5 minus 2 alpha. Okay. Now, when you want to multiply, you see that the combination of the lower part of this and also upper part of this, lower part of B and this one is different because of, you see, you will get minus 1, you multiply minus 1 here. Okay. When you multiply with 1, you will get minus 1. But when you multiply minus 1 here, with the 5 here, the combination of this, you will get minus 5. So meaning that when your minus, your x for ax here, when x between minus 1 and 0, the combination of multiplication between A and B is different if you are talking about the multiplication from x from 0 to 1. From x from 0 to 1 and from x from minus 1 to 0 is different. So what you need to do, you need to find what is alpha here. Okay, so that you can see for certain value of alpha, the combination to find the multiplication between these two alpha cut is a different one. Okay, so I will show to you. You can, I write again because of, so that it's easy for you to refer. Just now, we have A alpha is 2 alpha minus 1. Okay. And then we have 3 minus 2 alpha for A. And we have B alpha here is equals to 2 alpha plus 1. Then we have 5 minus 2 alpha. So, and then when you want to do this operation, so what you need to do, you need to do the alpha multiplication of alpha cut, which is, let's say you get C alpha here. Okay, so since the graph that I showed to you here actually producing a different combination of alpha cut, so you need to define that. So you can say that if your alpha is between 0 and 0.5, okay, because when we try to substitute this value, okay, when your x is equal to 0, inside ax, when x is equal to 0, so you will get half. You substitute that value inside this equation, So you will get A naught is equals to half. So meaning that if your alpha between 0 to 0.5, because again, we need to consider this alpha is equals to 0 and this alpha is equals to 0.5. Okay, so for that kind of alpha 0 and alpha 0.5 will give a different combination of multiplication. So where in this case, your A multiply B alpha, we are talking about alpha cut here, is equals to 2 alpha minus 1. Here, class, 2 alpha minus 1, you need the here. Okay, hold on. Here, you need to multiply with this one so that you will get the minimum out of the combination. So you need to multiply this with 5 minus 2 alpha. Okay. And then for the upper bound, so the same thing, I think this one is quite straightforward, where you'll get this one multiplied with 5 minus 2 alpha again. Okay. But if your alpha is between 0.5 to 1 here, so you need to get a alpha here. So the combination is different, where you still can use 2 alpha minus 1 here. Okay, sorry. Yeah, 2 alpha minus 1. But now you need to multiply with this one. So meaning that for the second one, you need to multiply, you need to multiply 2 alpha minus 1, which is the lowest of A alpha, and then with this one. So you will get, I think I put the green color so that easy for you to distinguish. So, and then the rest will be the same, which is 3 minus 2 alpha multiply with 5 minus 2 alpha here. So this is the difference. Okay, so you will get something like you need to solve these two value because of your A, B alpha here, okay, will give you different value when your alpha between 0 to 0.5 and when your alpha between 0.5 to 1. So, and then afterwards, when you use a first decomposition theorem, so you also will get a different type of, it's another level that you need to consider, because that x is depending on what value of alpha. You need to consider both of this one, okay? So the rest will be exactly the same like what you have just now. So the difference is only when you want to identify your what actually but either this one you need to multiply with this one, or this one you need to multiply with this one. So which one is the minimum one between these two combination? You need to be very careful. That one is depending on the type of your fuzzy numbers. Okay, any questions? Understood? Is it okay? No, no problem. Okay. So now maybe I also can give you another example, but I think this one maybe the student can basically try on your own. So let's say I have A. This one I put as exercise. So exercise, when your fuzzy number A, I just represent in term these two, 2, 3, 5. So let's say B is in term of 3, 5, 6. So from here, I think you can be able to see. And then what I want you to do is A, B. And maybe you can try on your own later on. Try and then you will get the answer, definitely. So next is, next will be, so this is the answer should be given to you about the example that I give you. So you can try this, the answer, then you can check whether the answer is correct or not. So if you don't have any question, class, maybe because this class is quite a quiet class, okay? I'm talk to myself. All right. So now look at into this one. D is just now we use alpha cut method. Now we need to consider the extension principle method. So again here, when we talk about extension principle method, so we need to focus to the fuzzy numbers which are in the form of discrete. Okay. So discrete form, okay? Okay, this is the one that I have shown to you yesterday. So we are using this formula, okay? Extension principle formula, which is this star here. We does not matter what actually the star is, so we still use supremum minimum here, but the difference is only how to choose your z. So your z is equal to x star y. If your star is addition, so z will be x plus y. If your star, you are doing the subtraction arithmetic operation, so your z will be x minus y. If you do the multiplication, so x will be multiply y, okay? And then when you do the division, you will get x over y here. So the rest will be the same, okay? So now we focus to the this one, okay? We try to focus to this one. Okay, you must remember that D is basically, okay, D is basically the fuzzy number given to you in the form of discrete one. So I try to give one example here, okay? So let's say D is subtraction. I think this one I already discussed yesterday. So now we go to the multiplication and division of fuzzy numbers. So to use the extension principle. So in this example class, I put my n or my we call integer. I put integer. Yeah, I do the correction a little bit here. Okay. Let's say we have fuzzy numbers both in integer. A is equals to the x here we put in this form. So you have 2, 3, 4, 5, 6. Okay. So the element of B in the form of 2, 3, 4, 5, 6, 7. So this is the correct way how to represent your fuzzy numbers A and B, where this is a discrete one. But I put in this table just for the sake of easy for the calculation, for the calculation purposes. So, but the correct way to represent your A and B actually in this form. Okay. So again here, you want to do the multiplication of A and B. So you can see here the boundary where you must remember, because this is fuzzy number. So definitely if you talk about your x equals 1, the fuzzy value will be 0. They cannot be, because fuzzy number is, we call it as a convex, okay? So also this one, if you have another element 7, so the fuzzy value will be 0 as well. So 6 here become the boundary one. Okay, the same with this one. And then you can see that the non-zero element of this to a multiplication of A and B, the non-zero element will be when your 3, you multiply by 3. So you get 9. So you try to identify the boundary first. So then what actually the element of A, when you multiply element of B, you will get the fuzzy value is equals to 1. I ask you. So this is very simple. You will get 4, 5 here, multiply. So you get this 20. So it's equals 1. So from this point of view, when you have this, so you have a formula to identify the multiplication or to do the multiplication operation on this one. So where you use this one, okay? You look into this formula. At the left, let us take into account, meaning that you have just now your x is equals to 20. When we talk about on the left, meaning that less than 20. Okay, yeah, let us take into account all couplets in the parentheses in this one when you multiply here. So we sorry. Why? Can you see my screen? Can you see my screen?
Yes.
Yes.
Okay. All right. Okay. So you see at the left, sorry, at the left, let us take into account all couplets in the parentheses, which is on this one on the left, as I mentioned just now. Okay, this one on the left, okay, on the left of 20, meaning that 19, 18, and just now we start with 9, 9, 10, 11, and so on. So we need to use this formula, where your x multiply d is very important. Your x multiply y must be less than equals to z. Okay, on the left. At the right, which is here, okay, at the right, let us take into account all couplets where x multiply x greater than equals to z. To simplify the process, you can omit consideration any couplets where at least 1 0 exists. Okay, so to just to simplify your equation. So I will show you one by one to ensure that you understand this one. Okay, let's say you take your 9. You want to calculate your 9 here. Okay, to get this value. I think I need one page. Okay. You want to when x is equals to, sorry, when your z is equals to x multiply y, okay, so now you take your z is equals to 9, you'll get 3 multiply 3. So this one is quite simple because you know that the z less than 9, which is definitely the fuzzy value is 0. So you need to use this formula. Okay, the formula that you should have, mu a b z, okay, should be equals to z is equals to x multiply y. Okay, then you have mu a x intersect mu b y. Okay, we need to use this formula. So this one 3 is very simple. So you compare this one to get mu c. I consider a multiply b is c. Okay, c here z is equals to you need to choose which one is the minimum between this value. You have 0.4 and then you have 0.1. So you need to choose the minimum one. So that definitely the answer is 0.1. So because between these two, you need to choose which one is the minimum one. So let's say you're looking for another, you want to calculate or CZ. So now I'm talking Z is equals to 10. Just now we are talking when our Z is equals to 9. Okay. This one, sorry. So this one is Z is equals to 9, you will get 0.1. So when Z is equals to 10, you need to consider also when mu, meaning that the value of 0.1 here, V, okay, 0.1. And then between, okay, I think it's easy for me to, or easy for you to understand if I write it properly, okay? This one is between, you want to get 10, you look into the formula again, how to get 10. So what actually the value of X and B to get 10? So you cannot actually multiply the value 3 is 9. 10, there is no multiplication, or 2 multiplied by 5. Here you will get 10, but the value is 0. So the minimum between 0 and 1 is 0. So 2 multiply 5, you will get 10, but the minimum, the fuzzy value will be 0. 5 multiply this combination 2, you need to choose either 0.7 and 0, you still get 0. So meaning that in that case, the value that you should get here will be 0, will be 0 also, but the answer definitely 0.1. So 0 here is actually A to multiply B5. This one 0 here is A5 multiply B2. So where both of this one you will get 0. So but you need to take the maximum one, which is 0.1. So that's why you will get 0.1 here. Okay. So you get the answer for this one also 0.1. Until you get 11, also the same thing, the same formula, because you cannot actually produce 11 by multiplying any number, any element from A and B. So in that case, you need to consider using this formula. You need to consider X multiply Y, which is less than equals to Z. So now look at another element. Maybe I can show to you a few elements more to make sure that you understand. So mu C Z is equals to 11. Also, you will get 0.1. So now mu C Z equals to 12. Okay. So again, you will get 0.1. So then we try to see what the combination to produce. Maybe I can drop this one. Okay. So now remember we try to get Z equals to 12. So the combination may be 3 multiply 4. So you get 12. And another one is 4 multiply 4 multiply with 3. Okay. So here, just now you understand that your Z is equals to 12. You will get 0.1. Okay. Then the next value you need to choose 3 here. Okay, 3 and 4. So the fuzzy value is 0.4 and 0.8. Which one the minimum? Minimum is 0.4. So then the other combination, the green color, this is 4, okay, multiply with 3. So you need to choose either 1 or 0.1. Which one is the minimum? So the answer will be 0.1. So that's why when between these three combination, you need to choose the maximum, which is 0.4. So that's why the answer here is, for the 12th one, is 0.4. So you need to continue until you get this one. So then afterwards, 21, 22, 23, 24, and so on, what you need to use? You need to use the second formula to get the answers. Okay? Class, okay? Are you fine with that? Do you have any questions how this calculation will be calculated in order for you to do the multiplication operation on using extension principle, specifically when your fuzzy number in the form of discrete. Okay, so really hope that you understand and use the formula given here in order for you to find out. So nowadays, because we have many tools in order for you to calculate, maybe you can actually put this one in the MATLAB or whatever for you to produce your answer if come out with any application later on. Okay, do you have any questions? So basically the same class for the edition one. Maybe you can try later on later. If you don't understand, actually, you can ask your Pak Jovian to have more discussion and so on with me. Okay. So the next, yes. Any questions? Okay. If you don't have, we move to the lattice of real number. So what the time now? So we have another uh 25 minutes. Okay. So lattice of real number, okay? So this lattice of real number, you look into the definition first. Okay, look into this one. So every pair of real numbers XY, we can define which one is the minimum, which one is the maximum one. So normally when we use the notation for the lattice, we use this one, So D is talking about the real number. D is basically the minimum notation for the lattice one. So then we go to this maximum, minimum, maximum of fuzzy number. So you look into this one. D is actually also I already include in my notes that I already share with Pak Jovian. Maybe Pak Jovian already share with all the students. You can refer further. And also inside my video yesterday, I also show to you how the operation minimum and maximum can be done. So don't confuse with the minimum with small letter, maximum on the small letter, because this one actually is different from the fuzzy intersection and fuzzy union, because we know that I think you have covered already the intersection, standard intersection operation, and also standard union operation on fuzzy set, which is we call it as T norm, S norm, right? Have you covered that? S norm, T norm. So S norm, T norm is the intersection. The T norm is intersection operation, and S norm is actually the union operation. Because fuzzy is quite unique, So they not like Cripps number. When you do union of a set,
Ini ini dokter normalnya ya yang lag ya, bukan saya kan ya. Seseorang mungkin respon, tuh ini ibunya ya yang nge-lag ya. Iya. Terima kasih Gabriel. Bentar ya, saya hubungin ibunya sebentar.
I'm just a brewing man. I know it make no sense, but to others,
Oke, ditunggu ya Ibu. Ditunggu dulu Ibunya ya.
Tadi saya cakap sampai mana? Tadi sampai mana lecturenya?
Sampai itu the different min max
Okay.
fuzzy intersection and fuzzy onion.
Okay, alright. I will. Alright. Okay. Can you hear me? Can you see my screen?
Yes, Doctor.
Yes.
All right, thank you very much. So this time, I actually would like to distinguish between the union operation and the maximum with the capital letter in a fuzzy number when we talk about latex just now. So now, you see, I tried to show to you how to get the uh, like x is equal to minus 2. When x is equal to minus 2, so a minus 2 and also b minus 2 will produce the same, which is 0. When let's say we increase x is equals to -1, you see a minus 1 and b minus 1. This one, a minus 1, you still have a is equals to -1. The fuzzy value is equals to something here, alpha. But for b, still 0. So, but we need to choose the maximum one. So, definitely the answer will be something like this. So, when x is increasing, so we will get something like this one. So, and then here also we'll get the blue color here, A. But when x is equals to here, we need to choose which one fuzzy value is this, which one is the maximum. Still, D is the same fuzzy value. But when x actually, beyond this value, okay, so let's say this value of x. So definitely here, let's say x is equals to 1. This one maybe x is equals to 2. So definitely we choose this one. Okay. And then the rest, we will choose this one. Okay. And after beyond this area, we choose this one. So this is actually the intersection of, to make it clear, I rub this. So the blue color here, I repeat, maybe I change the color. So this color representing basically the union of two fuzzy number. Okay, this is union of two fuzzy number. But when we try to do this operation, the maximum, how to do this maximum between A and B, maybe I use a different color. Maximum A and B. So the diagram will be different, okay? Because we are using a different formula for this one, So maximum, maybe I try to do on different pages. So maximum with a capital letter here between A and B. So D is Z. So we are looking for a different Z. Supremum, Z actually is, you need to choose the maximum between X and Y. Okay. Minimum AX and also BY. Okay. AX, BY. Okay. So you see, D is a different Z. Z, you choose minimum between X and Y. It's different as what you have just now. When you do A union B, we are talking about the same X. But if we choose maximum between AX and also BX. Okay. So this is a little bit different. Not little bit, it's totally different from what you should have. So again, when we try to sketch the diagram of that problem, okay, so let's say I sketch that two diagram again. So this is -2, this is -1. You have 1, 2, 3, 4, 4. So the first one is representing something like this one. Then you have 4 here. Okay. So for the B1, you have start from 1 and 3. So you have something like this. If you refer back to this one, the way you're doing this, because we are looking for the same value of X, the calculation from the left-hand side, you go to different value of X from your left to your right. X is equals minus 2, then you look at x is equals to minus 1, because we know that they are the operation on the same x. X equals to minus 2, x equals to minus 1, x equals to 0. Because between x is equals to minus 2, you need to choose the fuzzy number, the maximum fuzzy number between a, x, and also b, x. Which one is the maximum fuzzy numbers? It's not like what we have here. So here is a different. So instead of you choose the same x, but you need to identify your z for different value or for the maximum between x and y. So in order to do this, the methodology is not from left to right, but from bottom to up. From bottom to top, meaning that you need to look at the value of alpha cut. You start alpha is equals to here, something like this one. You fix the value of alpha. So from the value of alpha that you fix, then you need to choose between x and y, which one is the maximum. For the lower part, this is, let's say, for the lower part, okay, let's say with this is your x, okay. This is your y. So from x and y, which one actually the maximum? Definitely y actually the maximum. Okay. So then you increase your alpha. So again here, this is when x is equals to 0. But here when x is equals to maybe more than 1. So then you choose this one. The same case just now, just now for the upper part. Between this one and this one, definitely you need to choose this one, okay? Maybe different color. You need to choose this one. You need to choose this one. This one, you need to choose the other part, you need to choose this one. So you increase the value of alpha until you get something like this, okay? So the lower part between this and here, right? So definitely you choose the yellow one. Okay, the upper part is actually the same. So then afterwards, when x is equal, when alpha is equal to 1, let's say alpha is equal to 1. So of course you choose this one. So the diagram that you should have for this operation is this one, okay? Okay, I really hope that you can distinguish between maximum AB, Z with another one, which is what happened? Between this one, you try to see the difference between this one, and also what happened? Can you still see my screen? Between this one and also, yeah, the other one just now is the union operation A X union B X, where in this case we choose maximum A X B X. Okay, so this is two different operation. This one is two different operation, and we can see that we produce a different answer. This is the union one. This is the maximum operation with a capital letter. Okay, the yellow one, yellow color. So the same actually you use for the intersection. Okay, the intersection also actually you use this the same one. Maybe I can just, if we still have time, we can actually show to you. So for the I just sketch the diagram so that you can check your understanding when you try on your own. So this one you should have -2 just now. 1, 2, 3, 4. So you have something like this. So this is your A, and then your B is here. This is your B. Okay. So actually for the minimum one, I mean the minimum with a capital letter, you should get something like this. But anyhow, the same procedure. So this one is a minimum with capital letter. So another, maybe you can see the difference is -2, 1, 2, 3, 4. So the same diagram we show to you. This is so let's say this is A and B. Okay, this one you will get 0, and then something like this, and something like this, then finally we'll get this one. So this is a minimum, okay? This is a minimum mu AX, mu BX. Or in other words to say A intersect B. So this is basically the operation for minimum with a capital letter, A between A and B, and Z where we use this formula. Supremum, minimum, AX, BY. The formula is still the same, which is Z here is equals to minimum between X and Y. So this one actually is the same formula that we used previously when we talk about extension principle. So it's when we talk about extension principle, but in this case, actually more specifically, we are doing this one just now. Okay, so you see the formula is still supremum, minimum, AX, BY. So Z, this one is you need to choose minimum between X and Y. Just now, multiplication Z is equals to X multiply Y. Division Z is equals to X divide Y. Subtraction Z is equals to X minus Y. And then addition operation Z is equals to X plus Y. So the difference is only when you want to choose your Z here. So hope that you understand, class. Do you have anything to ask me? Questions? So this one is just another representation. But solving the fuzzy equation, I think I don't put in my lecture right now. Maybe you can try depending on depends referring to my notes given. Okay. So any question from the student? Okay. I'm sorry for the Wi-Fi interruption just now. I'm so sorry for the Wi-Fi interruptions just now. So there are another thing maybe later on when we have opportunity to share how those theory, how those methodology that I explained just now and also Pak Jervin explained can be implemented in the real world application when we want to calculate and so on. Maybe if we have opportunity, maybe I can take one real example later on to show to you, to share to you how this arithmetic operation works on that particular applications. Okay, with that, I leave it to Pak Jovian. Also, in my notes, there are some exercises. Maybe you can try And if you don't, if you have problem to solve regarding to that exercise, maybe you can refer to Pak Jovian, and maybe you can contact me as well. Okay? Okay, Pak Jovian.
Okay, thank
I
you
think
very
it's time
much.
already.
Yeah,
Mm.
yeah, thank you
I'm
very
so
much.
sorry for any gap, any lacking, any limitation because we are
No,
abroad. Yeah. Hopefully you understand, the student understand the concept of fuzzy arithmetic. So it only can be applied when the fuzzy set is a fuzzy numbers. Fuzzy numbers is a fuzzy set which is convex, normal, and bounded.
okay, thank you very much, Dr. Norma. Okay, for the insightful lecture to this two session of the UGC program. Okay, we truly appreciate your valuable time, willingness to share your expertise and knowledge with our student. Okay, on behalf of the Department of Mathematics, Faculty of Science and Mathematics, Universitas Diponegoro, I would like to express our sincere gratitude for this meaningful academic collaboration with UTM. Okay, we also sincerely apologize if there were any shortcomings during the program, whether in technical matter or even, yeah. Okay, before we
Sir?
officially
Yeah.
end today's session, we would like to invite all participants to kindly
Uh,
turn on your cameras, ya.
yeah, yeah.
Jadi anak tuh mahasiswa, mahasiswa, ayo kita
Well,
on cam.
actually, Pak Jovian, I have a few, video that I create using AI. For this session, but I don't have time to show to you. So maybe later on, or maybe I just give to you to share to your student
Yeah,
later.
okay, okay.
Mhm.
Maybe you can give me the link, okay. But
Yeah, yeah.
I will share. Oke, oke, mahasiswa, ayo kita on cam dan on cam aja ya untuk foto bersama di sini. Nggak usah pakai background juga nggak apa-apa deh. Ya ini biar kita pakai background juga lebih baik. Ayo,
Bahasa Pahantar di Undip bahasa Indonesia.
iya bahasa Indonesia.
Oh, I see.
Oke, sudah. Ayo yang on cam ini masih sedikit ya. Ayo Kak, saya tunggu dengan.
Nanti Pak Jovin share dengan saya gambar because I just can see you and me in this screen on this screen. And never mind, you just share with me later. Okay,
Oke,
when
on
you
cam aja nggak apa-apa
take
yang
the
pakai
photo,
HP
yeah.
ya. Pakai HP eh, nggak apa-apa, kita di on cam aja. Ayo ini di yang bagian kedua ini belum pada on cam. Ayo, ayo, on cam, on cam. Pakai background lebih baik. Kalau enggak ya nggak apa-apa. Yang sudah masih belum satu full ini. Ayo, udah ada backgroundnya kan ya? Backgroundnya nih kalau yang belum saya share di chat. Ayo ini apa namanya di chat ya, di kolom chat bisa digunakan untuk backgroundnya. Ayo ayo ini malah berkurang yang on cam. Ayo on cam on cam. Oke ini sudah mulai satu Baik, yang ada dulu ya. Baik, ini di bagian pertama. Ayo, on cam aja, on cam. Baik, saya dimulai ya untuk we all begin, Dr. Norma.
Okay, yes.
Satu, dua, tiga. Oke, lagi. Satu, dua, tiga. Yang bagian kedua ya. Satu, dua, tiga. Bagian ketiga, satu, dua, tiga. Oke.
Okay, nanti kongsi dengan saya gambar.
Ya, baik, Dokter Norma. Nanti saya share untuk for the
Okay,
YouTube link because I upload it to my YouTube and I give to mail so public can apa can see your lecture too.
okay, alright.
Oke. Once again ya. Okay, okay. Okay, we also like to thank all students and participants for your participation, yeah, during the lecture. Hopefully everyone gain the valuable knowledge and useful academic insight for this session. Okay, we once again let us give a warmest appreciation and big round. Tolong aplausnya ya buat Dr. Norma di sini ya, to our distinguished speaker, Dr. Norma. Thank you very much for the willingness.
Okay, you are welcome. So no problem. My
Okay,
pleasure.
okay. Thank you everyone. Ya, okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. So see you again later, inshallah.
Okay, see
Okay,
you,
bye
Dr.
everyone.
Norma.